AB Calculus Note Card 13, Normal Lines. This lesson 13 in the series of note cards that I'm doing is inspired by Stacy McMullen, formerly of the Dallas Penn School District, who developed the note card system in use today. And normal lines is an extension to the note card 12 lesson on tangent lines. And you can refer to that, and that could be helpful to figure out what's going on. And what a normal line is, it is a line perpendicular to the tangent line. And so we're going to just kind of make a sketch to see what that is. If we have a curve like this that represents a function, and we have a tangent line at a point that I'm drawing in here. Okay, this is going to be, I'm going to put tangent line. A normal line is a line perpendicular to the tangent line that I'm drawing here. So normal line. And I'm just drawing a little right angle symbol between these two lines. And the slope of a tangent line is, I usually refer to it as m sub t. And the slope of a normal line, okay, m sub n, equals the negative reciprocal, so -1 over m sub t. Now, as far as what is needed to find a normal line, we need the same things that are needed pretty much for a tangent line. So we need a point, a coordinate pair that I'm going to call x1, comma y1. Okay, that's going to be a point. And we need to have a slope. And the slope is going to be m sub n, which is going to be -1 over m sub t. And then the point slope form, just like we used for finding tangent lines, is y minus y1 equals m sub n times quantity x minus x1. And then we can pull these values out of our point we have. Okay, we'll go here. The y1 will go over here. The m sub n will go over here. Okay, and once we have all those, we have the equation of a normal line. So let's get to some problems. One, find the equation of the line perpendicular to the tangent line 2, and we have a function. I'm going to put over here on the right a point. And a point is an x-coordinate and a y-coordinate. And often we are given the x-coordinate to start with, as is the case here, which we have -4. Now we need to find our y-coordinate, and so we can plug in -4 to this function here. So we have 3 over -4 squared, which is going to be 3, and -4 squared is 16. So we have 3/16 as our y-coordinate. Next, we're going to need to find our slope. Our slope is going to be m sub n equals -1 over m sub t, or the negative reciprocal of m sub t. And so to find the slope, we're going to say h of x is equal to 3x to the -2 power. And where do we get this 3x to the -2 power? Because using the rules of exponents, we can move this x over to the numerator and change the sign of that exponent. And now we're going to take the first derivative of this function. So we have negative 2 times 3 x to the, we have negative 2 minus 1, which is negative 3. So we're going to have negative 6 over x to the third power. And next, if we plug in our value of negative 4, so we say h prime of negative 4 is going to be negative 6 over, we have negative 4 cubed, which is negative 6 over, and negative 4 cubed is negative 64. And the negatives cancel each other, so we get 6 64ths, and 6 64ths will simplify to 3 32nds. And that's going to be equal to our m sub t. And then to find m sub n equals negative 1 over m sub t, which in this case is going to be negative 32 over 3. So thus we say here m sub n equals negative 32 over 3. And we can now use our point slope formula, which is y minus y1 equals m sub n times quantity x minus x1. And for that, in this case, we have y minus 3/16, which is y1, okay, x1, y1, equals m sub n, which is negative 32 over 3 times x minus negative 4, which simplifies to x plus 4. So this is our equation of our normal line. Next, problem 2. Find the slope of the line normal to the graph of f of x equals 4 square root of x minus 2x at 9, comma, negative 6. And so we are already given a point. Now, often, as we've already noticed, you're given just an x-coordinate. Here, they've already plugged in 9 for x, and you'll see if you do that you're going to get negative 6 as an output. And so we're going to need to just find f prime of 9 to get our slope. So our slope, we'll put m sub n equals negative 1 over m sub t. I like doing this because this reminds us, easy to forget, and just put m sub t there. But now we're going to say f of x is equal to 4, and the square root of x is x to the 1/2 power, and we have minus 2x. And now taking the first derivative, f prime of x is equal to, we multiply this 1/2 out front times 4, and we have x to the negative 1/2, and then we have the derivative of negative 2x, which is minus 2. And 1/2 of 4 is 2, so f prime of x is equal to 2x to the negative 1/2 minus 2, and f prime of x is therefore equal to 2 over x to the negative 1/2 power is the square root of x, and we have minus 2. And so now we can substitute in the 9. So we have f prime of 9 is equal to 2 over square root of 9 minus 2. And that's going to be equal to 2 over square root of 9 is going to be 2/3. minus 2, and f prime of 9 is equal to 2/3, and minus 2 is going to be minus 6/3. So we get a minus or negative 4/3. And that's going to be m sub t. And so therefore m sub n is going to be your negative reciprocal, which equals positive 3/4. So m sub n equals 3/4. So now we can write the equation. Well, it says actually the slope of the normal line, doesn't it? Okay. So really, this is our answer. And if we wanted to, we could go and find more about it. That's why it's important to not necessarily box in what you're doing, because, well, anyway, that's all we're being asked. We'll just stop it right here. M sub n is 3/4. 3, if it exists, determine the equation of the line tangent to the following function at the breakpoint. And here we are introduced to two things that we've talked about, one of which was earlier, Notecard 6, which is continuity. And then we're previewing something that we're going to go over as the title of Notecard 14, which is differentiability. So I'm going to put differentiability test. And for continuity test, well, we know first of all that the breakpoint is going to be where x is equal to 1, because that's the point or x value in question. So for the continuity test, we need to have 1, g of 1 exists, and is equal to, it's going to be greater than or equal to here, so we'll have 2 times 1 plus 2 is equal to 4. And 2, we need to have a limit that exists, so we need to have, in order for a limit to exist, we need to have the limit as x approaches 1 from the left side of g of x be equal to the limit as x approaches 1 from the right side of g of x. Okay. And I'm kind of distracted a little bit here. Let me go ahead and put, we need a point and a slope, right? So point is going to be our x value of 1 and our y value of 4, if it exists, since that's the value we see here. Okay? And the slope, if it exists, we'll be able to put here. And it's going to be the slope of the tangent line, so m sub t will equal something. Okay, as we were. The limit as x approaches 1 from the left side is this 1 on top. So we say x squared plus 3 is equal to 2x plus 2. And if we plug in 1 for each of these, we get 1 squared plus 3. So I put 1 squared plus 3 equals to 2 times 1 plus 2. So we get 4 equals 4. So we say the limit as x approaches 1 of g of x equals 4, and then condition 3 is g of 1 equals limit as x approaches 1 of g of x. Therefore, g of x is continuous at x equals 1, or at the breakpoint. So next we use a differentiability test, and now we're previewing what you're going to see in Notecard 14. For differentiability, in addition to the continuity, which you've already determined here, and so we therefore have a value of a point that's valid, we have the limit as x approaches 1 from the left side, not of g of x, but of g prime of x, equals the limit as x approaches 1 from the right side of g prime of x. And so we're going to take the first derivative of the left side, which is going to be 2x, and the right side derivative is going to be 2. And when we substitute in 1, we get 2 times 1 equals 2. And we say the limit as x approaches 1 of g of x, or of g prime of x, is equal to 2. So that's our m sub t is 2. And so now we can write our equation for our line tangent, which is going to be y minus, and for 1 comma 4 we have x1 comma y1. Y minus 4 is equal to 2 times quantity x minus 1. And that's going to be the equation of our line tangent to the following function at the breakpoint. Next, 4. Suppose p and q are differentiable functions with the values in the table below. Find the equation of the line perpendicular to the tangent line of r of x at x equals -2, provided r of x equals p of x minus 3q of x. So we're going to have our point here. Okay. And we're going to need our slope, which is m sub t equals something. Well, already we're seeing that x equals -2. That's what we're given. So in the point here, we'll put x equals -2. That's our x1. And our y1 we don't know yet, but we know that r of -2 is going to be equal to p of -2 minus 3 times q of -2. And now we can just put what they are here. So p of -2 is going to be 5. So we have 5 minus 3 times q of -2. Well, q of -2 is 7. So we have 5 minus 21 equals -16. So -16 is what goes in here as our y1. Next, for the slope. Okay, we want to find r prime of -2. Well, that's going to be similar to how we found r of -2. So now we're going to take p prime of -2 minus 3 times q prime of -2, and that's going to be equal to p of -2 is -1, and minus 3, and q of -2 is 6. So we have -1 minus 18, which is going to be equal to -19. So that's going to be m sub t. Okay? So we say -19, but again, we're looking for the equation of the line perpendicular to the tangent line. So what we really need is m sub n, which is equal to -1 over m sub t. which is going to be positive 1/19. So that's m sub n. So the equation of the line is y minus y1, which is minus negative 16, so y plus 16 equals 1/19 x minus negative 2, which is x plus 2. So there we have the equation of our normal line or line perpendicular to the tangent line. So I hope these problems have been helpful to you, and this concept of normal line is just a natural extension to that of a tangent line. Good luck, and thanks for viewing.